name is Cristian Molina. I am a software engineering master's student. I recently graduated with a computer science degree. I am also the president of ACM. I'm the president of my ACM UTEP chapter in my university. And so ACM is this organization that is focused on providing career resources to its students. And we have been partnering with DeFi pretty much ever since the semester started. And we really like what you guys do. We participated on the face mask detection datathon, and we would like to keep learning with you guys. So this is why this workshop is happening.
Great. Yeah, thanks a lot, Christine. Thanks a lot for the introduction. And
thank you, man. Yeah, I am excited for this.
Yeah, great. Thanks a ton for that. And for everyone out there on YouTube and on Zoom, thanks a lot for joining in for the session. And just to give you some heads up, just give me 1 second. I want to set up the meeting controls. Okay, great. Okay, so basically, I'll probably start off with a bit of introduction about DeFi and basically, DeFi. We started with a vision to build data culture and democratize data science learning. When we say democratize data science learning, we pretty much mean that anyone without any maths or stats background should be able to come on DeFi and should be able to learn data science seamlessly. And coming to data culture, I believe, most of you know. So basically, if we take a very basic example of buying a stock in Facebook or Google tomorrow, so the first thing that we would do is probably we'll try and understand the trends in the last 6 months and see how is this particular company performing basically in the last 6 months, and who is leading it and what are their stock trends. And based on these data points, you try and make a decision whether you would want to buy a stock or not. Right. So similarly, we would want to inculcate and build that data culture in the way we work, way we operate, and way we learn, and pretty much anything, basically, so that we will be using data in an appropriate way to make meaningful decisions. So that's the vision that which we started with, where we would want to build that data culture and democratize data science learning. And here's a brief introduction about myself. I'm the co-founder of DeFi and also a founding team member of CompliData, where we help financial institutions fight financial crime like money laundering or probably terrorist financing and things like that, using machine learning and AI. Otherwise, I'm an entrepreneur, problem solver, and data scientist, and a marketer too. I love building communities and growing them. And that's a brief introduction about myself. And with that, let's get started. And if there are any questions, I think we have Gunika and Itlana on call, who will help us moderate the session. And just wanted to give a heads up, since the session is aimed for beginners who wants to get started. I'll keep it as intuitive as possible. While at it, we will also be covering some of the fundamental technical aspects. And we believe that, if one understands intuition behind an algorithm or a logic, they will have much better motivation to get deeper into the subject. So this is the pedagogy that which, we have been operating so far. And this has been something tried and tested in all our boot camps. And I'll also ensure that, the session is interactive. So I'll also probably ask few questions, and in case if someone has any doubts or something, you can feel free to put it on Zoom chat or on YouTube, and we'll be able to address them as and when possible. Okay. And so first and foremost, as a data scientist or anyone who is curious about data, right, the most important thing is to understand the problem that you're solving, or understand. In the case of businesses, you need to understand the business need or the business problem and their underlying concepts and context to come up with a solution for a given problem. Okay, so this is what a data science enthusiast or a data scientist should do in a business setup or in a real world problem solving setup. Let me confess, data science or machine learning is not about any particular tool, let's say Python or R or any other frameworks. It's all about solving a problem using data in a scientific way. So it's all about solving a problem. We'll dissect this statement in a while, and let me come to the learning objectives to begin with. So we'll understand the nuances of machine learning and its use cases to begin with, and then we'll go over understanding different types of machine learning, and then we'll understand some more keywords and go ahead with hands-on problem solving session. Okay. um, so yeah, so basically, like, let me quickly ask this question: what is machine learning? I'll probably check on YouTube. If someone can answer what is machine learning, that would be great. I mean, like, now you can put it on the chat. What do you understand and what is it in context to you? So that would be great. So in general, like, machine learning is a study of computer algorithms that improve automatically through experience. Okay, so basically, it is nothing but you're giving some inputs to the machine, which are nothing but data points. Okay, you'll give a lot of data points to a machine or the computer and ask it to give desired results. So this is what machine learning is all about. In nutshell, it's a new way of community and communicating your wishes to a computer. So that is what machine learning is all about. And let's understand it with some examples. Okay, so I'll probably, like, take you over through this example of email classification. Okay, probably, like, let me open my Gmail as well for that. So basically, I'll be talking about the classifying an email into a spam box or an inbox. So let's imagine you're working for, let's say, one of the two of the popular email clients are Gmail and probably Outlook, right? And let's imagine you're working at Google or Microsoft and you're asked to solve a problem. Okay, you're given a business problem saying that, hey, there are plenty of emails coming in, and why don't you classify them into inbox and spam box? Okay, so this is the problem statement that probably they would give. And uh, basically, like, what machine learning does is, like, you have to input a lot of data points into a magical box, which is nothing but a machine learning algorithm, and it would in return deliver and say that, hey, this particular email should go into inbox, or no, it should probably go to spam box. Okay, so this is what a machine learning algorithm does. Okay, so let's understand, like, what are the data points that we would be feeding into a machine learning algorithm. So if I go to my email, right, so this is how email a typical inbox or, like, promotion box looks like. So if I go over this email, the first data point that I see here is uh, basically the subject line, and then I see the name of the sender, email address of the sender, and then if I go a little further, I'll see, like, who is sending it and what time they are sending it and what kind of email domain they are using and bunch of other things. And then, like, comes the email body. So these are different data points that you would be feeding into a machine learning algorithm. And then eventually, as a data scientist, you will basically feed in all these data points and then ensure that a particular email is classified as inbox or spam box. Okay, so this is what typically a machine learning algorithm does, and this is a typical example. Okay, and how do you do it? So basically, like, how does this entire sequence of things happen? Okay, so first thing is basically you need to understand your objective. In the current case, the objective is clearly defined, that you need to classify and a particular email into spam box or inbox, right? So that is obviously, like, this is defined. And then next comes the data requirement and data collection. Okay, so initially, like, you need to basically, as a data scientist, you need to give a data requirement, or, like, collect all the data that is required to perform the analysis. And then you go ahead with something called as EDA and data pre-processing. Okay, don't get carried away with the jargons out here. EDA is nothing but exploratory data analysis, and uh, there is something called as data pre-processing. We will get to this in a while. Okay, we'll understand what it is all about. So in exploratory data analysis, we try to explore the data to identify if there are any patterns or to understand if there are any outliers in the data or anomalies in the data. And in the data pre-processing, we try to see if there are any missing values, or probably if we have to clean the data a bit, then we need to clean it. So for example, when you get the data, so when you, for example, if you're keeping a form, so let's say like, you're keeping up a registration form for an event that you're organizing. And let's say like, you have put a text, uh, let's say like, would you want to attend this session? Okay, someone would say that yes, I want to attend, and someone would simply say yes, and someone would say why, and things like that. So the data can be in an unstructured way if you have not collected in a proper fashion. So that's what we try to do in data pre-processing and data cleaning process. And then we go ahead with the modeling step, where we would be building a machine learning model, which is nothing but this magical box. Okay, and then that would basically give us the required prediction. Obviously, like, it doesn't, when we build a model, we also need to evaluate, right? So for that, we use some evaluation metrics too, and we iterate it for a while to get the best performance. And unless and until we are confident that, okay, this is the best one, so we iterate it for a while, and then we ensure that, like, once we know that, like, it's ready, we just deploy it on the live production and then monitor it. Okay, so just to show you how it looks like, so basically I have made a small this thing. So this is how a data can look like. Okay, Gunika, if there are any questions, just feel free to pick them up. Okay, so just to give some understanding, this is how a typical data can look like. A sender name for the email data set, right? A sender name, sender email, subject, body, and classification. So on this data set, you try to build your model. Okay, this classification is something that you would want to predict at the end of the day. Okay, we will get to that nuances in a while, but this is what you would want to predict. So on this data set, you would basically build a model. And then what you expect the data set to do is, like, in a real world setup, when the data is coming in real time, you would want the model to predict, hey, it should go to primary. Hey, it should go to probably promotions. Or if you're seeing something, I mean, probably it should go to primary. So this is what you typically expect a machine learning model to do. Here I'm doing it manually, but you would want to automate that. So that's what you would want to do by taking these data points. Okay, I hope that makes things clear. And let me just quickly check if there are any questions out there. Okay.
No, there aren't any questions yet.
Okay,
Just some responses on what machine learning is.
Okay, cool, perfect, great. I'll also
actually, I think that some people are trying to join the meeting through Zoom, but I think that it's locked.
Yeah. Can we request them to join in from
Okay.
YouTube? Is
Yeah, I can.
Fine? Yeah.
That's
I'm
fine.
sorry about that. Yeah. Yeah, so yeah, that's all about the data science process. We would also get into it in detail, like, in a while. And these are some typical use cases of machine learning. So we already spoke about email classification, right? So similarly, um, like, there are, like, number of use cases for machine learning. So in a typical setup, if I have to talk about the fintech industry, financial technology industry, in the case of banks, so you might have learned about credit card fraud detection. Okay, so basically, based on the transactions, like, you might have a transaction data set, huge transaction data set in a bank, and basically you can apply a machine learning model on top of that data set and identify whether a particular transaction is fraudulent or not. So for each and every transaction, you can write an algorithm and say that, okay, this particular transaction is fraud, or this particular transaction is not. I think email spam filtering, we have already spoken about it. Recommendation engines, I think on e-commerce platforms, you might have seen a lot of recommendations popping up on your personal account. So based on the previous search history of yours, the recommendation systems are giving you recommended products which are similar to what you have searched in the past. So these are some of the sample use cases, and not just that, like you can also go about with image recognition. Okay, I think there are plenty of use cases to talk about. I'll probably skip over this, and let's quickly try and understand some of the machine learning keywords. Okay, so first off, we will try and understand what is a label and a target variable. Okay, so target variable is that variable which you want to gain deeper understanding all about. Okay, so target or label. So in this particular case, if I have to talk about email dataset, classification will be your target variable. Okay, where you would want to classify a particular email into primary, promotions, or spam, or whatever it is. So here the target or label would be your classification. I mean, this field classification, and the rest of the variables that you see out here, sender name, subject, body, and others, they are nothing but your features. So basically, in the spam detection, I think I have already spoken about that. So that's something. And coming to input variables or features, I think we have already discussed it. So the rest of the variables that you are seeing out here are nothing but the features or input features or whatever it is. I mean, basically there are different terminologies that people use. For time being, we'll call it as features. And for the target variable, I mean, for the final prediction that we want to make, we will call it as a target. Okay. So in our case, in the email classification case, basically the target is nothing but classification, and the rest of the variables are features. So similarly, if I take another data set, it's a standard metropolitan areas data. So here, as you can see, there are different data points: person city, person senior, physicians, hospital beds, graduates, workforce, income, region, crime rate. So there are different data points. In this, you might be curious to predict. I mean, you might want to predict a crime rate in future when you get these set of data points. So in that case, the crime rate will become your target variable, and the rest of the variables that you're seeing out here, the fields, they'll become your input features or features. Okay. And in real time, basically, so basically you would build your model on this data set, and in real time, you will have all these data points, and you would expect your model to get this data. Okay, this is what you would expect in real time. Okay, so that's some context about what is a target variable and input feature. And I think we have already spoken about this example. And now let's get back to different types of machine learning models, or different types of machine learning. So typically there are three types of machine learning. One is supervised, and the second one is unsupervised, and there is something called as reinforcement. Okay, and so basically supervised learning is the most common sub branch of machine learning as of today. And typically new machine learning practitioners, or anyone who is wanting to get started with
Chanakya, can you please zoom the screen a bit, or put it in presentation mode?
Yeah, done. So
we have two questions, so we can take it right now.
We can take it. Yeah, we can take it now. Yeah, before we get started with this. Yeah.
So first is, what kind of size of data sets does machine learning? Yeah, I'm audible.
Yeah, it's audible. Yeah.
Yeah. So the first question is, what kind of size of data sets does machine learning work with?
What size, or what kind of size of data sets? Yeah, I mean, it can be
what
really
what
huge.
Range of sizes?
I mean, if I have to speak about some of the data sets that I have worked on, I mean, it can be in 2 million, 3 million, or 10 million too. I mean, it can be of any number. I mean, you can typically work on such kind of data sets. So yeah.
Okay. And the second question is that the daily meals of Swiggy is a spam for me.
but it's not for male. So how will we solve this? So, okay. So basically, this is a question to put it in context. I'm just looking at YouTube. So, like I have shown you Domino's email, right, which has gone to uh, promotions. Similarly, like, there is another vendor or another player out there called as Swiggy, who is into food delivery. So basically, all the emails of this particular company are landing into primary. Okay, you would want them to be in probably spam or maybe in promotions. So in that case, you need to teach the machine that, okay, it needs to be in spam. So if I have to teach the machine, in that case, I would probably go over here, rather I'll classify it into primary or whatever it is. So that way, the algorithm learns, and then probably the next time when you when you receive an email from Swiggy or Domino's, it gets classified into promotions. I think if they have automated that, if Google has automated that, then that's how it works. So yeah.
So there's one final question right now. What is the best way to classify emails into certain classes when only about 1,000 data points are given?
Okay. What is the best way to classify emails into certain classes when only 1,000 data points are? I think this needs a little more context. Probably we will go over the rest of the topics, and I think you will get a broader aspect on how to solve this. I'll pick this question at the end. Okay.
Yeah.
And let's get back to types of machine learning. So as I said, typically there are basically three types of machine learning. Basically, there is supervised learning, unsupervised, and reinforcement. So today we will be discussing about supervised learning, and is one of the common sub branch of machine learning. And anyone who's getting started with machine learning would start with supervised learning. And again, in supervised learning, you will try and solve two types of problems, that is classification and regression. We'll talk about this in few minutes. Okay. And coming to unsupervised, so basically on the other end, and I mean, in the case of unsupervised learning, you don't have a target variable. So coming to supervised learning, right? So there is, okay, probably now, I think, yeah, the slide is better. So in supervised, what happens is there is a clear target variable. So we just spoke about target variable and features, right? In the case of supervised learning, you have a clear-cut defined output that is nothing but your target variable. Whereas in the case of unsupervised learning, you don't have that target variable. What you do is you try to identify new patterns, new meaningful patterns with the help of unsupervised learning algorithms. Okay, so that's some context about supervised and unsupervised. And coming to reinforcement learning, I think reinforcement learning, it has a lot more, I mean, it learns from the interaction of an environment. So for example, if there is a game, I mean, it has a lot of applications in the gaming industry, basically. What happens is it basically enables an agent to learn in an interactive environment through a hit and trial. Okay, so it basically gets feedbacks on its own actions and experiences. And accordingly, it gives that reward points and kind of learn through the environment, okay, through constant positive and negative feedbacks or whatever it is. So it learns over time in a reward system. Okay, so that's some context about reinforcement learning. We won't go deeper into this at the moment, and it is slightly beyond the reach of this session, and it is fine if you don't understand the nuances here. So we'll be typically discussing about supervised learning, and just to show you some use cases. So machine learning has is of three types. One is supervised, reinforcement, and unsupervised. And in supervised, we have classification and regression. Okay. And in regression, as you can see, there are some use cases like market forecast, estimating life expectancy, weather forecasting. That means that you will be predicting what would be the temperature tomorrow, okay, at so and so time, things like that. And classification is you're talking about fraud detection, as I spoke just now, and email classification. So anything that's got to do with classification. And unsupervised and reinforcement, Probably I'll leave it to you to go through it at a later stage. And if time permits, we will discuss about it at the end of the session. Okay. So coming to supervised learning, right? The type of problems that we will be solving are two types. One is regression, and the second thing is classification. So a typical regression problem has basically the target variable is a continuous outcome. So that's one of the reasons I have picked these two data sets. So as you can see here, here if crime rate is the target variable, here as you can see it is a continuous value 75.55 or whatever it is. I mean, there is some continuous value. Okay, so this is nothing but a continuous variable. So these are the typical regression problems. And coming to classification, I mean, you classify. Okay, it would fall into one of the categories. Okay, so this is a typical classification problem where the target variable has different classes. Okay, and so to give you a simple analogy, okay, here, what is the temperature going to be tomorrow? It's going to be 84 degrees. I mean, it's 84 degrees Fahrenheit. But if we talk about centigrade, probably it would be between 34 or 35 or whatever it is. So that is nothing but a regression problem. And coming to classification, will it be cold or hot tomorrow, or will it rain or not tomorrow? So it is more to do with classification, yes or no. Or it can have more than two classes. I mean, it can be like, will it how will be the weather tomorrow? Will it be hot, cold, rainy, or whatever it is? So it can be more than two classes. Okay, so that's more about regression and classification. I hope it is clear. And yeah, and again, there is another example out here. So if you have a student profile, okay, let's say a student is there in a class, and he or she has a set of grades and a bunch of other things. And if we are classifying whether a particular, based on their grading system, whether they should be passed or failed, then that's a classification problem. And when it comes to regression, it is like based on the score they achieved in a set of subjects, they would get a total percentage. So which is nothing but a regression problem. Okay. In regression, the target variable will be continuous, and in classification, the target variable will be a category, or it has different classes. Okay, so that's some context about classification and regression. So yeah, and now we will also talk about a little more about the machine learning workflow. I mean, the workflow of a supervised machine learning algorithm. So first and foremost, we acquire data. Okay, as we discussed a while back. So we collect the data and we define the data requirements and all, right? And after that, we clean the data. Okay, after cleaning the data, before even building a model, what we would do is we would technically segregate, or partition that particular data into three different data sets. One is train, validate, and test. Okay, and we would be using this train data set to train the model. And then we'll be using the validation data set to test the model. And finally, to evaluate the model, we'll be using test data set, and eventually we'll be deploying it. Okay, we will probably understand in detail in next few slides. Okay, first of all, let's understand what is train, test, and validate. Okay, so train data set, let's simulate ourselves into a exam setup. Okay, and let's understand the prominence of each of it. So let's understand. I mean, let's take an example of exam. So you are preparing. Let's imagine you are preparing for an exam, and you started learning, right? So that learning process is nothing but a training data set. Okay, let's imagine that way. It's like basically you're training for the exam. Okay, that is nothing but you're training or learning for the exam. That is training. And then you practice. I mean, on the validation data set is we practice by doing exercises before the exam. So we pretty much whenever we are done with our preparation, we would try to give some mock tests, right? Or we would try to simulate the real world uh, exam setup and try to practice it. Okay, that is nothing but the validate data set. And then comes the real exam, where the test data set is nothing but you're giving a real test after preparing or getting trained for the exam. Okay, so these are the three different data sets with analogies. I hope it is clear. So in training, you learn, I mean, like, and you train yourself. In practice, you try to validate what you have learned. And in the real world setup, in a real world exam, you try to give the test based on the trainings that you had on your trained data set. So now let's understand, like, what is the prominence of these test, train, and validate data sets. So let me ask you a question. What if the paper gets leaked? Okay. What would you do? Probably, like, I'm just checking on YouTube. So let's imagine, like, you were preparing for the test, and 2 days before the test, a friend comes to you and says that, hey, the paper got leaked, and probably you need to learn these questions. So what would you do in that case? Yeah, someone answered, if the paper gets leaked, your test data set becomes your learning data set. Yeah, that's true. Actually, like, what happens is, once you get to know that, okay, the paper is leaked, and once you get those questions, what you would do is you would train yourself on that particular leaked paper. Okay. And meanwhile, like, if the university gets to know that the paper got leaked, and if the test paper changes in the last moment, you'll be amused, right? Like, you have trained yourself for the leaked paper. Okay, you have overfitted, or, like, I'll speak about overfitting in a while. You have completely trained and memorized everything that you get in the leaked paper, and then eventually in the exam, and then the last minute they have changed the paper, and you will be like gone. I mean, you may not have performed the way you would have had you trained yourself well, right? So you have basically, like, accustomed yourself to train on that particular league paper. So this is a classic case of overfitting on the trained data set, and then, like, when it is shown to an unseen data set, that is a new test paper, you will be you'll be gone bonkers. Okay, so that's some context about train test and validation. And the crux of the story is, we should never expose our test data while training a model. Okay, so just to give you put it in context. Okay, this, you should always train your data set, train your model on the trained data set, and you should never expose this test data set to your model at all. Okay, if you expose it, you would end up giving that data to the model training, and it might as well produce good results when you are testing it, but when it is put into production, it fails. Okay, I mean, it sees a new data, and probably it will also predict, but the prediction wouldn't be that impactful. Okay, so that's the downside you would have. And yeah, basically someone is asking, why is it important? As I said, I mean, probably we will talk about how and why it is important in a while. The thing is, like, when in the hands-on session, you will be able to understand a little more about it. So yeah. Okay, this is another slide where we have explained where you can use train data set, validation, and test data set. Okay. um, so basically, you use train data set to train your model, and validation data set to validate your model, and tune some parameters, if any. Okay, and coming to test data set, once you are done with the training and validation, you would do a final check on the test data set, and then check its performance and put it to production if that is good to go. Okay. However, for simplicity, what we would do is, in the current session, we will only be using train and test split. Okay, and we'll get to this later on. Okay, so now let's get to the problem solving bit. Okay, we are very much on time, and yeah, and also like someone asked why is it important, right? So whenever we build a model, right, we are basically building a model, a machine learning model on a historic data set. Okay, on the past data set. And what this model does is it would probably after building the model on the historic data set, this model will be exposed to the new data set. Okay, so hence it's extremely important that the learning happens very properly while building a model. Okay, if you expose your test data set, right, what the model does is it memorizes that test data set. And probably when you throw some new values to the model, it would end up throwing some skewed data, or something that is not appropriate, okay, or not optimal per se. Okay, so that's where we end up with overfitting and underfitting. I'll also take you through overfitting and underfitting probably, and I'll show you how it looks like. Okay, so this is a typical case of overfitting and underfitting. Okay, as you can see, overfitting is nothing but here we are showing that a person wearing dresses, okay, a suit basically. Here this particular person seems to have overfitted his suit. Okay, so it's a case of overfitting, and coming to this looks like a perfect fit, and this looks like an underfit. Okay, but I think you need a lot more context before we get to this. Okay, I'll probably go over to this. Okay, let's probably play around with the data set. Okay, first of all, in the problem solving bit, we need to define objective or understand the problem statement, right? So in today's session, we'll be playing around with okay, we'll be playing around with liver data set. Okay, where the data set contains I think 583 records in total, if I'm not wrong, of which 416 are having liver disease, and 167 are non-liver patient records. Okay, from a South Indian state of India. Okay, so we have in total 583 records, and the objective of this particular problem, or objective of this particular thing, is to predict. I mean, based on the data points that we have, okay, these are some of the data points that we have. Based on the data points that we have, we need to predict whether a particular person, an individual, would have a liver disease or not. Okay. So first and foremost thing, we need to understand our data, define our objective. So the objective is defined, very well defined. We want to predict whether an individual has, will have liver disease or not. And data requirements, we already have the data points. So we don't really need to go and collect the data, or define the data requirements. So this is, to be honest, one of the most difficult parts in a real world setup. But here in our case, we already have it. So it's straightforward. And then we go about with exploratory data analysis, data pre-processing, and others. So let's go over it one by one. So first thing is we know what data set is all about. Okay. And so we can read it. Patients with liver disease have been continuously increasing because of excessive consumption of alcohol, inhale of harmful gases, intake of contaminated food, pickles, and drugs. Basically, this data set was used to evaluate prediction algorithms in an effort to reduce burden on doctors. Okay, and basically, the algorithm is supposed to help doctors, and let's see how it helps doctors. Okay, first and foremost, we have our data points, right? One is we have age, we have gender of the patient, total bilirubin, and there are a bunch of other keywords, as you can see, proteins, albumin, and this is our target variable. Okay, as I said, I hope you still remember what is target variable and features. So these variables, or these data points, are our features, and this is our prime focus. This is what we would want to predict. Okay, and it has 1 and 0. It is a binary outcome. 1 is nothing but have liver disease, and 0 is nothing but no liver disease. Okay, so these are different data points that we have, and you can find the data set here. So if you want to look at the data set, this is how it looks like. Okay, this is the data set. Okay, for your understanding. And okay, for those who are not aware of what I am using, okay, I'm really sorry. I should have introduced all of you. So I'm using something called as Google Colab. Okay, you can search for it. Google Colab is nothing but a online virtual environment which allows you to run Python scripts. Okay, for especially it is built for data science and machine learning, deep learning practices. So you can just search for Google Colab, and it will allow you to set up your own virtual machine in less than a few minutes. Okay, you just need to go to this, and if you want to upload the notebook, just upload it here, or you can also take it from GitHub. So for example, I think you might have got this one, right? So this is the link that you might have received. So all you need to do is copy this link and paste it here. Okay. Oops. Okay, I think I didn't do it well. So I need to click on upload and then click copy paste this and click on enter, and then I'll see this. Okay. By clicking on this, you will be able to open your own virtual environment, and that's it. Okay, so it's as simple as this. Okay, and let me go over step by step now. So first and foremost thing is we need to load some libraries. Now, what are these libraries? I don't know if everyone knows about libraries or not, but for those unattended, libraries are nothing but so I'll probably explain you with an analogy. Okay, so for example, if you have to buy vegetables, what would you do? Probably you will go to a nearby store and buy the vegetables, right? Okay, so that is one of the ways you can do easily. And there are other ways too, where you can probably farm them from scratch and probably produce them. Okay, where you plant, sow seeds, plant, and then get the vegetables by producing it from scratch. Okay, by farming it. So putting this in context, so libraries are like shopkeepers. Okay, basically they have already built everything from scratch and put a ready-made code for you. You just need to use some of the functions, and you will be able to functions in the libraries, and you will be able to uh, apply some really cool machine learning algorithms. Okay, whereas if you have to build it from scratch, yes, you can do it. Probably instead of running the algorithms in a few lines of code, you would end up writing some 20, 30, or maybe like 100 lines of code. That's the only thing. That's the advantage that you would have. So there are a lot of open source contributors on Python who have created these very good packages like sklearn, matplotlib, and things like that, which will make the life of a data scientist very easy in terms of running their own machine learning models. Okay, so that's some context. And so yeah, that's some. So basically, first and foremost thing is we need to load some of the libraries. Here we are loading three libraries, as you can see: pandas as PD, numpy as NP. So PD, import pandas as PD is nothing but PD is like a alias name. Instead of writing pandas in entire, I would rather use it as PD wherever I use it at the bottom. Okay, same with matplotlib.pyplot as PLT. So instead of using this entire thing, I would rather use PLT. Okay, wherever I recall it in the next few sets of codes. So if I have to run this, I'll just run it. I'll import all these libraries. And then first and foremost thing is I need to read my CSV. I mean, I need to read my data. For that, I need to use this function called as pd.readcsv, which belongs to pandas library. Okay, I'll read my data set, and I'll probably do a very basic exploratory data analysis. I won't get deeper into scheme of things. So what I'll do is I'll use this function or module called as .head, which would allow me to generate first 5 rows. As you can see, I can see the first 5 rows. I can see age, gender, total bilirubin, and all the data points technically. So I can see each and every data point. Okay. And going further, I can check what are the different column names that I have. For that, I just need to use dot columns. Okay, I'll just skip it. If you want to run, you just need to run it this way. And the easiest way to run a particular piece of code is Control Enter. That would also allow you to generate. And now this is something important. So I'm using this function called as .info. Liver data is nothing but, okay, I forgot to mention this. Liver data is the data frame name that I have given while reading the data. That's why I'm using that. Okay. So now I'm using liverdata.info. What it produces is it gives me non-null counts of each and every field or each and every column that is available in the data set. So as you can see, each and every column has 583 no-null points. Okay, and also it gives me the data type. All of a sudden, you will see, okay, there are 579 for this particular feature, albumin and globin ratio. That means that there are 4 null points. That means that four values are missing in this particular column. Okay, so that means that there is an issue of missing. So how do we deal with missing values is one question. And the other thing is coming to, if you analyze this data, particular data, all the data points are in numerics, okay, except for gender. And let me tell you, when you run any machine learning model, right, all the machine learning models expect the data to be in numeric format. Okay, so we need to change the data of gender into a numeric as well. Okay, so we'll also see how to do that, and we will also see how to fix this problem of missingness. Okay, missingness of 4 values. So first thing is what we would do is, so we will also get the value counts of liver disease and not. I mean, this we already know, but you can basically there is a function called as value counts, which would give you how, like, the class of a particular variable. So in this, the count of a class of a particular variable. In this case, liver data is the data set, and liver disease is your column name. And value counts is giving the counts of liver disease, different classes of liver disease. So 1 is nothing but who has liver disease, and 0 is the people, like, who doesn't have liver disease. That's what I believe. Yeah. You can see, yeah, 416 liver patient records. So similarly, I'm really sorry. So similarly, if you want to understand the value counts for something else, you can do that. So all you can do is you can apply the same thing. Probably I would want to know the value counts of gender. So what I would do is just go to type gender and check. Oops. Okay, basically I Python is case sensitive, so I gave G as small caps. So basically we have 441 male patients and 142 female patients. That's some interesting data point if you want to note. And we can do a lot of exploratory analysis and come up with some nice data visualizations too, if you want. But I'm not getting into that. So now I would want to understand what are those null points. So what I did is, like, I wrote a small piece of code here. Okay, inside the liver data, I tried to access this particular variable which has null points.
Hi, Chanakya, yeah. Can you please zoom the screen a bit?
Is it visible now? Is it fine?
Yeah, much better.
Yeah. And then, okay. So basically I was trying to capture, or like, I was trying to get what are all the null values in this particular data set, right? So what I'm doing is, like, I'm calling the data frame, and then I'm accessing the particular column and then checking for the null values. Okay, this is what I have mentioned in the code, and then you can see that, like, these are the 4 records which have null value as which for which albumin and globin ratio has null values. Okay, cool. Now that we have this, now what we need to do is we need to fix this, right? We need to apply some remedy for this missing values. So typically, like, the best practice is generally, like, we try to fill the missing value with the mean of the entire column. So what we have done is like, in this particular context, we try to fill it with mean. And if it is a categorical variable, then probably we would go with a mode. That being said, there are better methods to solve the missingness, but at the moment, like, we'll probably go with the easiest one, that is mean. And it is also robust per se. I mean, it is appropriate to use it. So yeah, I'm just filling the missing values with mean of this particular column, and that's done. And now the next thing is, as I just mentioned, gender column is a categorical variable, that is, it has male and female. So what we need to do is we need to convert it into numerical format, right? So to convert it into numerical format, also there are a bunch of other ways of doing it. So one of the ways to do is one-hot encoding. Okay, so what is one-hot encoding in the first place? So in one-hot encoding, what happens is basically one-hot encoding creates new variables or new features with different categories in the variable. Okay, let me explain what this statement is all about. So for example, here we have gender, right? Gender has two classes. One is male and female. Okay, so what one-hot encoding does is, instead of having just gender, it will create two other features, gender male and gender female, and convert it into binary classes. I mean, like, it will convert into a form of a binary outcome variable. So let's see how. So after running this code, what happens is basically, the variable gender will vanish, and you would get gender female and gender male. Okay, and if a particular record is a female, then you would get a value of 1. If it is not, you would get a value of 0. Similarly, if a particular record is 0, I mean, like, is male, then they would get 1. If it is female, they would get 0. Okay, so we are basically, what's happening is one-hot encoding just creates new features with different categories of that particular column. Okay, in this particular case, gender has two categories, female and male. So we have created gender female, gender male, and we are converting into binary outcomes. Okay, I hope that makes it clear. And we have also added one small image, probably, like, you can also go through that. And after doing it, so let's go over to the machine learning flow, right? Let's see what's happening exactly out here. Okay, we already know the objective of the problem, right? So basically, we are having a lot of data points, and we need to feed into a machine learning model that would give an outcome of whether a particular patient has liver disease or not. So keeping this aside, let's look at the machine learning flow. First thing is data acquisition, data cleaning, all these things are done. The next part is, like, we need to do this step, right, where we need to split the data set. So that's where we are. But in the current context, what we are doing is, instead of splitting the data into test, train, and validate, what we are doing is we are just splitting the data into test and train. That's it. Okay. So the model will be trained on trained data set. And then after the training is done, we will validate, or, like, we will evaluate the model performance on the test data set. So we are only splitting into two parts, that is test and train. Okay. So we are, remember, we are not going to expose our model to the test data set. What will happen if we expose? Basically, like, the model will learn the data points in the test data set too. So, and it will memorize it, and it will end up overfitting on the existing data set that we have. And when it is exposed to the new data set, when it is exposed to the real world, then it ends up performing bad. Okay, because it has already memorized only the set of data points that you have given. Okay, so keeping that aside, now let's go to the next steps. So in order to split the data set, first and foremost, what you need to do is you need to separate your input and output features. Okay, basically output is nothing but the target. So what you're trying to do is here, I hope I have run this. Yeah. And then what you're trying to do is you're separating your input and output features. So your input, your features are nothing but all the variables except for the target, right? So you're running this particular command to be able to get all your features, and you're storing it in X, okay? And you are storing your target variable in Y. Okay, so this is how it is done. So you have separated your input and output features, and then you go ahead with splitting them. Okay, you go ahead with splitting them into test and train. Okay, let's for this to happen, what we would be doing is we would be using sklearn train test split module. Okay, as you can see, so we will be importing this module from this particular library. Okay, and also let's go over it one by one. So as you can see, there is something called as xtrain, xtest, ytrain, ytest. What is xtrain, xtest, ytrain, ytest? Okay, it's nothing but train and test variables. Xtrain is nothing but all the features of your test set, and xtrain is nothing but all the features, of your training set. Same with ytest and ytrain. Ytest is nothing but your target variable of your testing data, and ytrain is nothing but your target variable for training the model. Okay, so you're splitting them into, it's nothing but like, you're splitting them into train and test. Okay, so you're just having 4 more here because you have already split them into separately into X and Y, which are features and target. Okay, that's the reason you're getting 4 different sets of data. Okay, now what you would do is you would split the data. Okay, and while splitting, what we have done is we have taken test size as 20% and train size as 80%. That means that if you have 583 records in this data set, 80% of the records have gone to the training set, and rest of the 20% have gone to the test set. So we will be training on the 80% of the data set and then testing it on a new unseen data of the 20% remaining 30%. And there is something called as random state. Okay, so why do we even use a random state? Okay, so basically whenever we do this splitting, right, it automatically randomizes the data. Okay, the particular function that we are using, it automatically randomizes the data. And for every iteration, I mean, like if I run it now without using random state, I might end up getting different um, test data and different train data points. Okay, and if I run it after 10 minutes, or like after, I mean, if I run it immediately after this, I might get different sets of data points. Okay, so to keep it consistent, what I would do is I would use a random state. Okay, so basically whatever you do in any setup, right, be it in software development or machine learning or anything, the results have to be reproducible. So that's where random state would help you reproduce the results. Okay, basically when it comes to training and testing data sets. Okay, when it comes to splitting them out. Okay, now that we are done with this, the next we'll quickly go over things. So the next practical setup is we would be building a model, and in this particular case, we will be building a decision tree classifier. Okay, so the end outcome would be to basically we will be having all the data points. Okay, and we will be building a decision tree classifier, decision tree, to be able to predict whether a particular patient has a liver disease or not. Okay, so that's what we would be doing. So we would build a very basic decision tree here. Okay, and just yeah. So now coming to this, I believe everyone knows what decision tree is, but I'll definitely go over it on and explain like what a decision tree is all about. So just to give you an very simple analogy, right? So if you are making a decision, or like, if you're trying to predict the mileage of a car, okay, you would probably start by asking this question: what is the, uh, I mean, is the weight of the car heavy? Yes or no? If it is yes, then you would say high mileage. Okay, it has a high mileage. Basically, like now in this particular problem, what you're trying to do is you're predicting the car mileage. Okay, so you are considering a particular car to have high mileage if its weight is heavy. Okay, you will define what heavy is. Probably you will define in kgs or lbs or whatever it is, whatever metric it is. So, and then you would, first question you would ask is whether it is heavy or not. If it is heavy, high mileage. And if it is not, you would say that you would ask another question whether the horsepower is uh, less than or equals to 86. If it is less than 86, then yes, it has high mileage. If it is no, if the answer is no, then it is low mileage. So this is what a typical decision tree does, where like, it will ask a bunch of questions, and based on the results, it will make a decision. Okay. So here the decision is high mileage, here the decision is low mileage, and here the decision is high mileage. So for each and every data point, it asks a bunch of questions. Okay, it goes over and over and asks a bunch of questions, and then based on that, like, it will make a decision. Okay, for software engineers out there, it could be treated like a if else loop, but yeah. Similarly, I have another example of predicting the house price. Okay, here does first question you would ask is, here you're predicting the price of a house. Okay, and the first question probably you would ask is, does house have more than 2 bedrooms? Yes, no. Then, like, if it is yes, if the lot, like, is the lot size larger than 11,000 square feet? Yes, no. Okay, if it is yes, then the price would be this, and if it is no, the price would be this. Same goes here. You're asking a different question, and you are making a decision, or like, predicting something. So this is what a typical decision tree is all about. So we'll be building our decision tree out here. So in order to build our decision tree, again, like, we need to use a particular library called sklearn, and we'll be importing decision tree classifier. Remember one thing, it's a classification problem. Okay, why is it a classification problem? Because here the end outcome, as I said, like, the end outcome out here is we are predicting whether a individual has a liver disease or not. So the outcome is classifying. It's not a continuous outcome. If it is a continuous outcome, then it would be a regression problem. Okay, I hope, yeah. And coming back, so that's why, like, we are basically using decision tree classifier. Let's run it. Okay, and I'm using this particular, I'm calling it as a D3. And so we first import this, then we need to feed the model into our data set, X-train and Y-train. That is nothing but our train data set, right? So we always train the model on our train data set. So the next thing that we would do is we'd build the model, and we would basically fit the model on our training data set. Okay, that's what we are doing here. D3.fit X-train, Y-train. Again, like, here we have used random state to keeping into consideration of consistency and reproducibility. Okay, so now I run this, and then I get my decision tree. Basically, we have built a machine learning model already. So you can see there are a bunch of things here which are called as parameters. Okay, we'll talk about these parameters or hyperparameters in a while. Okay, so let's keep that aside. Now that we have built the model on the training data set, so it's very simple. To be honest, like, building a model is very trivial, especially building simple models is very trivial. So now that we have built the model, what next? The next thing is to test the model, right? We need to test it on and evaluate it. Okay, so now while testing it, what we would do is we would test it on a test data set. Okay, how do you do it? So in order to do that, okay, if I have to test my model, then the first thing that I would do is I'd probably write a piece of code like this, and So you have fitted the model here, you have built the model, and the next step is you have to predict it. So you will use the same function that you have used there, basically d3 dot predict. You will be predicting on the trained data set. So it's done. Okay, you have predicted it. And then this is basically you're building it on the trained data set. And then you'll predict your accuracy score on the test as well as the trained data sets. So what you would do is you will just you just need to, there is something called as accuracy score. So just for your understanding, obviously once you build a model, right, what you would do is basically you would have to use some evaluation metric. Like in our exams or in back in college, what happens is you would get a set of grades, and after getting that set of grades, the next thing that would happen is you would be given some let's say distinction or excellence or whatever it is, some you will be put into some category, right? And similarly, so basically what happens here is you need to evaluate it based on some metric. Okay, so similarly, like we have exams, similarly, we have something called as the evaluation metric, and there are different evaluation metrics. One of the fundamental, or one of the simplest evaluation metric that's out there is accuracy. Okay, which is not an ideal metric for all the for all the problems, but for simplicity we'll be using it here, and it is relevant in a lot of problems, but it again depends on the problem to problem. So typically when it comes to classification problem, there are also other evaluation metrics like F1 score and AUC, ROC, and things like that. But here, we'll keep it simple. And accuracy is nothing but number of correct, you'll be, accuracy is the number of correctly predicted data points out of all the data points. Okay, so you will just get that, okay, if you have predicted, let's say 10 data points, and out of those 10 data points, 7 are correct, then your accuracy will be 70%. If out of 10 data points, if you have only correctly predicted 1 data point, then your accuracy will be 10%. Okay, so here we will check the accuracy score. I think I'm really sorry for this. Just ignore this piece of code for the moment. And yeah, what I'm trying to do is I'll probably predict the accuracy on training data set as well as on the test data set. Okay, so in order to do that, I need to put both the things on the prediction in this particular thing, in this particular function. So I'm using an accuracy score function from sklearn metrics library. Okay, so this is what I'm using right now. So as you can see, the train accuracy is 1.0, whereas the test accuracy is 0.6. Okay, someone was asking, why do we even need to segregate it, and why do we even need to analyze it on 2 different data sets? So here we can see that it is a clear overfitting where it is giving the best performance on your training data set, whereas when it comes to a new data set, that is a test data set, it has given only 60% accuracy. That means that if you have 100 data points, only 60 data points were predicted correctly, and the rest of the data points were falsely classified. Okay, so this is where I think we need to be a little more diligent, and this is a clear case of overfitting on training data set. So what we need to do is we need to be a little diligent and also tune and optimize our model so that it doesn't overfit on the training data set. So in order to remove that, so what's happening here is it is memorizing completely on the training data set. So what we will do is probably we will tweak the model a little bit, okay, and see if it can improve the performance. So right now, as you can see, I'm also visualizing this model. For that, you can use this library called as there is something called as GraphViz. You can import it and try to visualize how your decision tree looks like. So here, as you can see, the decision tree is asking plenty of questions. Okay, it is asking plenty of questions, and it is making a decision. Okay, this is not something very optimal. In fact, here we have very less data points, right? We have hardly probably 12 to 13 data points and we are still able to visualize. But what if we have hundreds of data points? Okay, we will also discuss what if we have hundreds of data points, what we need to do. Okay, and whether all the data points are they relevant, or do we need to select only few of them which are very relevant? So we will also address this question in a while. So basically, it is asking a lot of questions, and in fact, those many questions may not be required. Okay, it is a very complex model, and probably what we can do is we can do some kind of a pruning, or we can decrease the depth of the questions. Okay, let's say here there might be some the model might be asking 15-20 questions or so. Okay, the depth might be 15 or 20. What we will do is we will decrease the depth out here. Okay, and see if it increases the performance or not. Okay, so this is the improved model that we have used, where we are trying to optimize it. Okay, so we are calling it as model improved and fitting it on our training test data set. And as you can see, the maximum depth that we have given is 3. Okay, we have randomly picked the maximum depth as 3. However, if you want to optimally arrive at this, there are different optimization techniques like grid search and random search and things like that, which can basically fit the model on different depths and finally arrive at that particular depth, which is producing the best prediction accuracy or predictive power. So, and then let's check the predictions. And as you can see, the train score is 0.74. Okay, test score is 0.67. So as you can see, earlier the test score predictive power was, I think the accuracy was 60%, and now it has increased to 67%. However, the train score earlier was 1, and now it is 74, which is fine. So earlier it was overfitting. Now it is, I think, it is not overfitting for sure. Okay, so this is an example, and we can, yeah. And also you can visualize it now, and it's also very simple to explain anyone. Okay, so this is the question that you are asking, and you are making a decision based on it. Okay, so in this particular case, the first thing that the model is asking is the direct bilirubin less than or equal to 0.85 or not? Okay, and if it is true, then it is putting it here, and if it is false, it is putting it here, and then it is asking one more question, and based on that, it is classifying whether a particular person has liver disease or not. Class is equals to 0 implies that the patient doesn't have liver disease, and class is equals to 1 implies the patient has liver disease. I'm sorry, I think someone is asking some question. Gunika, any questions, or we are good?
Yeah, we do have some questions. I think
yeah,
you can
probably
wrap up.
yeah, we will wrap it up, and probably next thing is we'll be building another model that is nothing but a random forest. Okay, it's a slightly advanced model, and yeah, so basically a random forest is nothing but a bunch of decision trees bundled together to get more accurate and stable prediction. This brings us to discuss a downside of decision tree too. In decision tree, what happens is, even if you misstep in one of the choices, okay, let's say you have this decision tree, right? If you do a misstep in one of the particular steps in making your choices, it can lead to a completely different end. Okay, for example, instead of it being 0.85 to something else, and it would lead you to probably in this particular case, right, instead of this particular value being 19.5, if it is 21 or 22, it would probably these two results would be very different. So that's what I wanted to convey. Basically, one single misstep in the choice of nodes can lead you to a completely different result, and choosing the right branch instead of left could also lead you to furthest end of the tree. So basically, if instead of choosing yes or no, if you're choosing true, then it would take you here, and if it is if you're choosing the left branch, then it would take you to a different point. So that's the downside of decision tree. Whereas what random forest offers is it overcomes all these hurdles. It overcomes most of these hurdles, and as it is a collection of decision trees. Okay, so it is what it does is it's called as ensemble model, where it gets the data points from a bunch of decision trees and then does the prediction. Okay, I'm not going to go deeper into this because it would be a slightly overkill. And like, and I'll probably keep it simple. So it's an advanced version of decision tree where, like, you are making your prediction more accurate and stable by using the decisions of a lot of decision trees, okay, put together. Okay, so for that, like, we'll probably be using random forest classifier. We'll be importing it, and then it's the same thing, same steps that we have followed earlier. We'll just use it and print, and then we'll check the predictions. Okay, we'll check the accuracy, and we can see that here again the train score is 1 and test score is 0.63. So again, like, it is overfitting on the training data set. So what we would do is we would improve the model by, again, here we have picked maximum depth as 3, but you can change it, or, like, you can use some advanced optimization techniques like grid search or random search to be able to optimize these parameters. So maximum depth is one parameter that we have chosen. There are other parameters too, as you can see. There are a bunch of other parameters. Okay, these are the parameters, and it's a different concept altogether, or a topic which takes a lot more time to explain, which is called as hyperparameter tuning, which can improve your results big time. Okay, so after using this this algorithm, we can see that okay, let me just run this, and then yeah. The random one is not fitted yet. Call fit with appropriate. Yeah. So basically, I didn't run this properly. Now, as you can see, the train score is 0.77 and test score is 0.68. It didn't improve the performance much because it's a very small data set. And however, like, if you play with large data sets, you will probably see some difference. However, it is more robust than a decision tree for sure. And when you put into production, it will probably produce better results. So that's some context about how to build a machine learning model. So I think during the hands-on session, you might have understood what overfitting is all about. So it's like to give you a classic example again here. So overfitting is nothing but you're fitting the data completely, like, you're memorizing the entire data and fitting it to each and every point. This is how it looks like. And and if you ask me, like, what is an appropriate fitting, it would look somewhat like this. Okay, where you're classifying the circles and cross marks with a parabola here, and it is nicely, like, classifying it. And underfitting is like there is a lot of misclassification out here. As you can see, this particular line is supposed to classify circles and cross marks, and as you can see, a lot of cross marks are misclassified as circles here, and that is a classic case of underfitting. Okay, so out of this entire exercise, what have we achieved? Okay, and what else can be done is something like, I'll quickly take 1 or 2 minutes. So what else can be done in general to optimize this particular thing further, right? So one thing is we can do something called as feature selection. So what is feature selection? So right now we have a lot of data points, right? So we have a number of data points. As we can see, we have so many data points. Okay, in this case, we still have very few data points. But what if we have 100 data points, or let's say 250 data points, or whatever it is? We need to go for those features which are more appropriate, or, like, more meaningful for us to make decisions, right? So in that case, what we would do is we would use feature selection, and we can also optimize it further with cross validation and applying different machine learning models. So random forest and decision tree are not the only models. There are other models too, and there is something called as hyperparameter tuning. As I just explained, in this particular case, right, we only spoke about one parameter out here, that is maximum depth, but there are a bunch of other parameters, okay, that you can play around with that could potentially improve your prediction power. Okay, so we can play around with it. That can also potentially help increase your predictive power. And what have we achieved out of this entire exercise is basically, if you look at it, I mean, like, if we are able to build that efficient model, we can technically empower doctors for treating liver patients. Okay, so when, like, a particular liver patient, a patient comes and goes through a certain test, what this model does is it will basically predict, it will give doctor a hunch whether a particular patient would have a liver disease or not. Okay, it would give them that sense that, okay, whether they would have it or not, and they can easily investigate the case further. Okay, and it would also help them avoid errors. By chance, if the doctor misses out on one of the data points and it is I mean, it can cost life, right? So basically, it will help them avoid the errors. In practical, a real case, there is another advanced use case that I've worked on in the past, where like, using the Parkinson disease using Connect. But probably, like, we'll skip this for now. But there are a bunch of use cases like this where you can technically empower individuals or practitioners with data and with machine learning and data science, so that they can arrive at meaningful decisions using data. And that's it for the day. And thanks a lot for everyone. I thought, like, I'll wrap up the session within 75 minutes, but we pushed by 7 minutes or so. I'm really sorry about that. But I'm open for questions. So
Yeah.
Yeah.
So we have some conceptual questions.
Yeah.
If you can throw some light on validation data. So someone asked that he has been using train test split to split the data into train and test, and it has been working fine. So what exactly is the need of validation data there?
Right. So yeah, that's a good question. Actually, if I show my data, right? So yeah, it works pretty much well if you use train and test. But if you are going for some hyperparameter tuning or something, right, and where you would not want to directly test it on a test data set and would want to use it on a separate data set like validation, what happens is, like, you can technically optimize your hyperparameters by testing it on validation data set and then exposing your entire model on the test data set. So it will give you a breakthrough there. So it will help when you are tuning the model.
Yeah. Also, like, sometimes, like, the test data set that we consider is actually can be considered as the validation data set as well, and test data set can be considered as the unseen data that we find in the real life scenario that does not actually have any labels.
Yeah, exactly. So yeah, that is quite that's a valid thing. Totally agree. And
yeah, also I think you've already covered that pretty well. There was a question that was asked before about if you can explain overfitting intuitively but in a little technical terms. So maybe you can throw some light on it again, just a little, or maybe just how to know if the model is overfitting.
Okay, how to know if a model is overfitting, right? So for example, in this particular case, okay, we have a very classic case out here. So if you look at this particular case, right, we have fitted a very basic model, and on the trained data set, it is giving you a accuracy of 1. That is, like, it's 100%. I mean, and when you see this, you should be super confident that, okay, there is something wrong with the model. Okay, because it's I mean, you can't be 100% accurate. So, and as you can see, like, when it is exposed to the new data set, okay, the accuracy is 63%. Okay, 0.63. There is a huge difference between test accuracy and train accuracy. That itself says that, okay, there is a huge difference, and you can call it as a overfit case. And if I have to explain it intuitively, I think this was already, I think this is one of the cases that we can go through, where this is the case of overfitting, where you're fitting the data into granular parts, where you don't necessarily need to fit these points. It's all right to be misclassified, because when you build a model like this, Okay. It is fine. It goes well on trained data set, but when it is exposed to a new data set, which is not at all seen by your model, then things will go for a toss. Okay. This is probably the best model for this data, but it won't be the best model for the new data that the model will be seeing over time.
Yeah, that was nicely explained. Also, someone asked, how did you decide the depth as 3?
Okay, that's as I said, I mean, like, I just went with a random number. That's not the optimal way of doing it. So in fact, like, if you ask me, the optimal way to do it is probably using some optimization, hyperparameter tuning techniques like grid search or random search, which would probably, like, what it would do is it would iterate over different depths and arrive at a depth which is providing you the optimal scores, optimal prediction, I mean, optimal accuracy, or whatever the evaluation metric is. It will give you the optimal score there and throw the final result. So it's just a random number that we went with. Yeah.
Yeah. Also, someone asked if you can explain the concept of bias variance trade-off, but that might be a little too
Yeah,
far
that might
from
be
the
a
scope.
little, yeah, slightly out of scope. So I'll probably let it be. And
Yeah.
yeah, and one quick thing. So for those who would want to get started, right? I think we have a brilliant library. So this is probably, like, one of the best that you can find. So if you ask me, there are plenty of courses out there which are available for free. There is plenty of learning material out there which is available for free about data science, machine learning, and a bunch of other things. So what we have done is we have recently conducted 2 boot camps. One was on deep learning and machine learning. All of it, like, delivered by some of the best data scientists out there from industry and academia. So what we have done is we have conducted this 5-week data science boot camp during the months of May and July, where close to 15 plus industry speakers have come into deliver different sessions on different topics. So what we have done is our team, like, basically Gunika, Manish, and others have basically put it together and put it on the on our Learn platform. So you can technically enroll for it for free and learn different techniques out there, different optimization techniques. Here you can see on week 4, there are different model optimization techniques. And the thing that Gunika just asked about bias and variance, we have intuitively explained about that particular concept in one of the weeks. I'm not sure which week it is, but probably Gunika, you might. I'm not sure if it is on top of your
Yeah,
head, but yeah. Yeah,
that's around week 2.
week 2. Okay, great. So you will find it somewhere in week 2 about it, or and also we covered it in some other weeks too. So you can technically go through it. It's probably one of the best. And yeah, yeah. Any other questions or
Yeah, we actually do have a few more questions. So one was a personal question
yeah.
about just a second. So as a third year computer science engineering student looking to pursue a career as a data scientist or analyst, how should I proceed ahead? I've done the theory in my college course. So how
Mhm.
can you proceed?
Sorry, I didn't get the question. So basically, he's a third year computer science
Yeah, a
engineering
third year.
student.
Yeah,
Yeah.
completely. And he has done some computer science theory in his college course, and
Mhm.
he wants to pursue data science or data analysis.
Okay. Yeah, I think that's an interesting question that you asked. Actually, like, when I was attending one of the live sessions the last week with, I think it was delivered by Coach Chef with the CTO of Swiggy. So many people ask this kind of question. So it purely depends on case to case. So if you're really passionate about data science, machine learning, and things like that, and it would be good to start off with probably something like Kaggle, or first understand the practical aspects of it, understand, like, how machine learning works, and try to play around with some real world data sets, because the data sets that you see on most of the courses is, or, like, pretty much on in most of the MOOC courses is very glamorous, whereas when it comes to the real world data set, it's a lot more unclean and and it's dirty that way. So you need to put in a lot more effort in terms of cleaning the data and then producing some meaningful results. So what I would suggest is take probably like Kaggle competitions or any other, even for that matter, our datathons. Okay, you can take that as a practice ground and try to implement them, do some projects, and if you're really liking it, just complement it with your computer science engineering background, and probably that would be the coolest thing that can happen ever. And then once you are able to build those projects and build that visibility, right, you should be able to be employable by any other organization out there. So once you get things right, I think selling yourself, marketing yourself among the employers to be hired is the most trivial thing. Yeah.
Yeah. So someone asked if time series analysis is important in data science field, and can you please tell us a few examples of time series analysis in the same field?
Okay, time series. Okay, that's a very interesting subject. I think it's mostly used for forecasting, be it let's say forecasting sales or for that matter stock prices and things like that. Yes, it is important. It is one of the growing fields, and it's very important, I would say, for a lot of organizations. But if I have to give some examples, as I said, one is stock market predictions, or even for that matter, even cryptocurrency and things like that. They do it using time series predictions, and you can see some really cool graphs on different websites about that.
Yeah. I think we can take one last question. It's a general question about what's the difference between machine learning and data science?
Machine learning and data science. Yeah, okay, that's a very good question. So data science is more of a multidisciplinary field, which involves data analysis, data visualization, part of machine learning, AI, and a bunch of other things. Machine learning is more about, as I said, like, it's all about building models and different other things. So data science is about, it's a multidisciplinary field. It covers a lot more things. You think like a business person, you need to understand the business context and different other things. So yeah, machine learning is more of a core technical thing. Yeah.
Mm-hmm. Okay. There's one request about if you can take one session for time series.
Mm-hmm. Yeah, I think maybe we can find some really good speaker who can deliver that. And if you know someone like whom you think is the best, please feel free to suggest, and we will arrange a session on that. Yeah.
Okay. I know I said the last question, but there's another interesting question, which is, I think, quite popular as well. So I know for a fact that getting internships and jobs without any experience is really difficult. So do you have any tips on how to get professional experience?
How to get professional experience? I think build some cool projects. Okay. So let me tell you, I myself have hired a lot of people. Okay. With no experience. Okay. Across different fields. If you ask me, like, I have hired people in software engineering, data science, marketing, mostly in marketing and community and things like that. So I think if you can showcase that you are very much interested into the field by putting up some cool projects, I think that's one of the biggest validation for any recruiter out there, saying that, hey, I mean, like, this particular individual stands out because they have built something cool and they have been active in it, and you have to stay on top of your game. Okay. And don't give up. Most importantly, let me give you one more thing. I think I should do this. So basically, when I applied for my first internship, I mean, when I say first internship, first abroad internship, I had this fascination of applying for foreign internships. So one of the key factors out there is, yes, definitely didn't have any experience out there. But one thing that definitely helped was applying to a lot more people. Again, just don't randomly apply to people. So what I did is I applied to a lot of professors and research laboratories back then. What I did is, like, I tried to understand what a particular lab is doing, try to understand whether it aligns with my objectives and my research areas of interest or not. And if it aligns, I used to write a motivation letter in context and used to apply to them. Okay. And it shouldn't stop with one application or two applications. You have to be persistent. You have to apply those processes rigorously. And I mean, in getting my internship, I probably applied for 350 plus and ended up getting some 4 or 5 internships, abroad internships back then. Yeah, I think it's all about showcasing your technical depth and breadth by staying active, by doing projects, by competing in some of the data science competitions and things like that. And after that, applying with persistence. Don't give up. Giving up is not an option. Okay. So just consider that and just apply the process well. You should be there.
Yeah, that's some really valuable advice. So thank you so much, Chanukya, for this wonderful, wonderful session. We have a lot of thanks pouring in and a lot of requests for future sessions as well, since they found this worth attending and
Yeah.
really worth their time. So
Thanks a lot, Gunika, for the moderation, and thanks Itlana on the other end, and Manish for the time, and Christine Molina. Thanks a lot for the invitation. Wouldn't be possible if you wouldn't have invited me, because like now this is the live session I'm doing after a very long time. Don't have a big motivation after a long time. I mean, it's because of me, I was able to do this. Thanks a ton for that. And yeah, so for the rest, I think like you know where to go when it comes to learn machine learning or whatever it is. I think I'm just putting up the link out here on the chat. Probably go over there and we'll find some resourceful material. Thanks a ton, everyone. And Christine, you want to add some final notes? In fact, if you want to add to the students at your campus.
All right. Yeah. So this was so nice. Just let me thank you, because you don't know this, but yesterday I was talking to a couple of freshman students, and they were telling me like, you know what, I really want to like start applying for internships, and I really want to go to this workshop, but I don't know anything. Like, I don't know Python, I don't know about data science. This is my first class. Like, I'm barely starting in computer science. And I really appreciated how detailed you were on having people with no experience in mind, because you were explaining all the Python libraries, what they are, what they do, and I think that you're a really good professor. And so for my students, thank you guys for coming. Thank you guys for making this possible. And I hope that all of us can come together again and like so in my hope in doing this is that we can keep participating on your datathons, because on the last datathon, the face mask detection, we just like what you guys do, and we didn't know anything, so it was like super hard to like tackle these things without knowing about machine learning, without knowing much about Python. But the desire was there in my organization, and I was really happy to see my people getting excited about this competition. So I'm hoping that these workshops help them to give them the tools that they need in order to solve you guys' puzzles and datathons.
Yeah, totally. And thanks a ton for that. And for those unattended, I think you should go ahead and go and apply what you have learned on this datathon. And yeah, I think that's a good point that you have mentioned. I mean, one has to practice over time, Christine. I totally agree. I mean, they have to practice again and again and stay on top of their skill. That's extremely important. And thanks a ton for joining in. Thanks a lot. And take care, everyone. Yeah.
Thank you so much. Take care. Bye-bye.
Yeah, bye. Take care.